yesterday we created one web application, right? Okay. So we saw like what are the advantage of a web application, like if it is a standalone jar file like this, and you want to give it to all the 100 users, but if you deploy an application in a web server so that all the 100 users can access it using the URL. And also dynamicity can be achieved using the servlet web application, any web application. So a web consists of dozens of clients and servers connected through wires and wireless networks. Our goal is to build a web application that clients around the globe can access and to become obscenely rich. The clients who are connected in the internet can access through the server. There are a lot of protocols involved in between. In the network layer, there will be a TCP, IP protocols, and there is also something called network stack, right? Presentation layer, and please do not throw session plate always. Data packets, all this going to happen. So we don't want to go at socket level. So we don't want to do some research on that topic. Just we can understand like, okay, there are clients who are being interconnected through the server. So they can send a request to server. The server could be a web server or application server or database server or FTP server, anything that it be. Its purpose is to service the client. Any client can post a request, or you could get a pages from the server, or it could be a database where you could process some data into database and you could get it from the database. So this at the overall at a higher level. Let's see a little bit deeper. So what does your web server do? A web server takes a client request and gives something back to the client. So web browser lets users request a resource. So browser is like a client through which a user is going to place this request. I need this page. HTTP :localhost 8080 index.jsp. This is the page I request. Or user. So this is one application. I want to show you this web application. Just a matter. Copy it, and which is built on Spring and hybrid framework. So let me log in with any ID. So I use MySQL database and it is connected, and this data is coming from my database. Okay, and this details, and there is also a request form. If I want, this is a project actually, which is did by one of the students actually. So if you want monitor connection or new computer, you want to click here like I want to add some comments, and if I submit this, it will be posted to the network admin, and he will see, okay, this user requires a computer connection, so he will try to build it. Okay, so he will try to make a report of it. We can create the users here. Where is that here? Admin can create the users. So whatever we enter here, it will be go and inserted into the database. Here we are requesting for this page, login.jsf, and here we request for some network. Okay, here also same page but different UI. UI is getting changed. So web browser gets the web request resource, and web server gets the request. Okay, so it is running in my local host here. Where is the server here? So I have deployed it network admin application, and I've also logged few transactions. Actually, it is getting logged here. So web server gets the request, finds the resource, returns something to the user. You are of course quite familiar with found not found errors. Response you get when server can't find. It thinks for when if we request for some of the resource, it will say like page is not found. So it's not right? Yeah. There's a lot of error codes are there. We will see like if it is 500, right? Then connection not find like that. Yeah. Gateway exceptions and user authentication, it will throw 403. So if you want to authorize this page, authenticate and authorize this page, then if he is not a valid user, then it will turn 403. So you will see also that. And when we say server, we mean either physical machine or a web server application. So here server machine is like my laptop is a server, and I have software, Apache Tomcat software, like which is going to which is going to receive the request and process the request and send the response. So in my software, web server application software, I have one container called web container, which is our Tomcat container, who is going to handle each and every request from the client and take care of life cycle of the client, life cycle of the request and responding to the client back. So it is just an example, like web browser is there. The client request contains the name and address of the URL, the thing client looks for, and server usually has a lot of content that it sends to the client. Content can be web page, JPEG, or other resources. Even this jar file, right? We can send it in the response. There is something called content type.
Maybe gzip or something, right?
Yeah, yes, you're right. Yeah. And web control. Double click. Yeah, content type. This is just an HTML and XML content, text and XML. If you, this response, right? Response, we have set like content to be default text and XML. If you want, you can send also jar files from server.
Okay.
If you send jar files, then you can download the jar file in this machine, and you can click on the jar file and you can execute the, you can see the application. Even that we can do. So server response contains actual document, it contains the client request, okay, this is fine. And what does a web client do? Web client lets the users request something on the web, on the server, and shows user the result of the request.
Yeah.
Okay. Browser is a piece of software that knows how to communicate with server. Browser other big job is interpreting the HTML code, rendering the web page for the user. The client is browser app doing what user asks it to do.
Yeah.
Okay. So server and client knowing HTTP and HTML, no HTTP. So let's see how client and server talk to each other. So there should be one language which both should understand. That language is HTTP. Hypertext Transfer Protocol. Rules have been defined there. So how we should send a data packet to a server, how to send a request to a server, and how a server can, and only then a server can understand that. So we need to use this protocol. If you see any web application, right, there will be this protocol HTTPS, which means a secure layer. We want to give a username, password to access this host. And also this, okay, this is just straightforward HTTPS and also HTTP. So server often sends browser a set of instructions and written in HTML, hypertext transfer markup language, and HTML tells the browser how to represent the content to the user. Okay, so this browser, right, at the back end, there is one the interpreter which is going to interpret the response. Okay, here you could see the response, right? XML, partial, pages, C data, and all those things. So it is going to get this response, and browser is going to interpret that each and every tag, whatever it gets from the, whatever it gets in the response, all those things. So it is going to interpret that and it is going to render it. At the back end, how browser is going to work is like there will be a JavaScript which will form a document tree, which will create a tree based on the root tag and side tags. It will form a document tree. Amazing. This is the main. Okay, this is the main object, document object created by the browser, and using this document, right, we can access any element. Get element by ID, get element by type, get element. Lot of methods are there. This is JavaScript actually. So the JavaScript, it reads the HTML response and it renders it. That's all the rendering thing are taken care by the browser. This is just an example. User clicks a link in the browser, browser formats the request and sends it to the server. Server finds the requested static page, and server formats the response, send it to the client. Okay. So HTTP protocol, most of the conversation held on the web between the client and server are held using HTTP protocol, which which allows for simple request and response conversations. Client sends an HTTP request and server answers with HTTP response. Bottom line is, if you are a web, we speak HTTP. So hypertext stands for protocol. And these are different type of servers and ports through which we need to, port in which the application is running. So we need to send a request to that port. If you're talking with HTTP, right? If you want to talk to a server using HTTP, then you want to talk to this port. If you want to upload or download a file, then we'll use FTP protocol, file transfer protocol, simple mail transfer protocol. All these are servers, SMTP server and HTTPS secure layer. So well-known TCP port numbers for common server applications using one server app per port, and server can receive up to 6555 different server apps running. So one server, there are 65536 different ports are there. So in each port we can run different applications. This is just a simple example what we did yesterday. Like we created one form and action, we gave the servlet name, and we're going to submit the parameters param1, param2 to this servlet. And in that servlet we wrote one print writer, right? Print writer, and we wrote output.print writer. Okay, hello server, we wrote this one, username and parameter which we rendered in the UI. Let me click and run it. Okay. It should be right. Okay. I'm going to use to render it. Okay, fine. So HTTP runs on top of TCP IP stack. So this is a protocol like internet protocol. Like TCP is responsible for making sure like file is sent from one network node to another, ends up on complete file at the destination. So TCP, right? So each data will be divided into datagrams and data chunks, and it will be sent into the nearest server actually.
Yeah.
So I don't want to go a bit deep. Just let us see this slide. So TCP is responsible for making sure that file sent from one network node to another ends up as a complete file at the destination. So TCP is responsible for making sure that the file sent from one network node to another ends up as a complete file. Okay, this is fine. IP protocol moves above that packet. HTTP then is another network protocol as the features. The thing is like there are two methods, get method and post method, important methods. Apart from that, there are also delete, put, and all the different methods which we will use while posting a request to a server. So HTTP request, a key element of the request stream, HTTP method action to be performed. So and page to access URL. Okay, format. Okay, these are some examples. Key element of response stream. So in response, right, we will have status code which will tell whether if it is 200, right, it is success. Request is response is success. So if it is 404 not found, 500, then there is some gateway 443 gateway exception, 502, 505 gateway exception like that. Content type, we can see the actual content. So all those things here actually in the response stream. The request and here is the response, right? For this post you will see so status code is 200, this is the post method, and this is the URL, and who is the agent, like from we have sent the request from Mozilla browser, and we also have something called sessions, cookies, and all those things which are very important, and we will see in our coming classes. And yeah, what are the parameters we posted? We posted all these three parameters, and response we got. This is the response we got. Yeah. So Apache is the example for web server that processes the HTTP request, and Mozilla is the example for a browser that provides user with the means of making HTTP requests and to view the documents in the Apache server. So HTML is a part of HTTP response. HTTP response can contain HTML. HTTP adds hidden information to the top of whatever the content in the response. Okay. So HTTP protocol has several methods, but one you'll use most often are get and post. Other HTTP methods are like get, head, trace, put, delete, option, and connect. Connect is used to connect to the servlet, and delete is used to delete some contents in the server. Option is like you can send some other optional elements in to the request, and put is like if you want to put some files into some location like that, and trace to trace the request, and And yeah, get, mostly we will use get and post method. There are difference between get and post, like if you want to get some content from the server, only then you want to use get. Like if you want to get some static pages, static content from the pages. If it is a login form, you want to post these parameters into server, then we will go with post method, posting all this data to the server. Get is like getting the content from the server, and another one thing is like if you say get, all the parameters will be appended here. Get equal to value. Suppose that could be a password also, or credit card information which will be going here. Credit card, something like this, and the numbers will be going here. So it is not safe, and also this space, right, it is limited. You can't add more than 512 KB data here.
Okay.
If it goes like this, the parameter is very big, then if you keep on adding, right, it will exceed. So it will exceed the total space. So it is very bad idea to use get method in order to submit a page, submit a form which contains a lot of parameters in it. So you want to use post method. If you use post method, all this data will not go here. It will go as a separate request here. Specific request data, it will go here.
Okay.
So that's our solution here, right? Let us cover. So it is post method. So where is the data trend and data request parameters? Here you could see it as a parameter, it goes in separately, but it didn't go here because we used post method. Let me make it to get. Okay, pre-publish, publish. So the simple, let me try to do this one, right? It is going here.
Okay.
Get method is not supported. Why we are getting this? We are getting 405. A method is not supported exception from the server because we don't have do get method in our servlet.
Yeah, we have.
We are only to get. So now let us refresh this page and let me say ABC 112. So it goes here, right? So this page is limited. We can't send more parameters. This is actually one idea. We should not send it here because this is a form and we're going to post it. So we should use post method. Okay. So HTTP request and response, when browser finds opening called HTML tag, it goes into an HTML rendering mode and displays the page to the UI. When browser gets an image tag, it generates another HTTP request to get the resource described. In this case, the browser will make a second HTTP request to get the picture referenced in the image. So if you specify something src equal to HTTP, again you are pointing to another one folder inside your server code and some images from this location. So again it will be a new request if it is an image or any document if you could refer. If you refer any document, right, which is just sliding into the server, so again it will be a new request. So that is the reason in that network app we were able to see 4 requests. One get and very many, one post and many get. So this is just an anatomy of get method. It is going to contain the and we will have the encoding standard here, encoding zip type and character set 180 and connection keep alive. And here important thing is which is the host. So which host we are going to talk and to which host we are going to post the request to post this parameters.
Yeah.
And from which browser, from Mozilla. So, and this is a anatomy of post request. Here you could see the color and size goes at the bottom as a parameter, not appended to the URL. So, get browser sends HTTP get asking the server to get a page. Browser sends HTTP post to server giving a server what a user typed in the form. So we're going to
Okay.
post some content in the UI to a server. If you want some static pages, we will go with get method. Or I'll send for uniform resource locator where our server, so this is actually our IP, right? Let my IP will be like, wait, let us try to, you try to access this application from your machine, okay? Let us try to get our IP. So static web pages and dynamic web pages, there are two things.
Yeah.
Static pages just sit in the directory. When server finds it, hands it back to the client as it is. So every client sees the same thing. So static web pages like could say, so these are all documentation, Spring documentation. Okay, these are all documentation, and it is going to be static every time.
Yeah.
Docs. It will not change.
Yeah.
But if you see a trading site, it will keep on changing, right? Date and the share of price or share value will keep on increasing and decreasing. So those are dynamic examples for dynamic web applications. So sometimes you need more than just a web server. So here is a simple program, whatever we did yesterday, like I created one servlet which extends the HTTP servlet. Rather than extending, we can go with annotations, which is standard in advanced servlet API. So we can make use of this annotation and we can create one servlet and we can access the servlet. So if you don't use servlet, right, let me remove the servlet. And then we need to configure the servlet in the web.xml file.
Okay.
Servlet. And then servlet mapping. Here we should have servlet name and URL pattern or class name and comes this servlet name. Servlet name. So there are pros, advantages and disadvantages also. So if you do it in XML, right? So it will be like a configuration file. And tomorrow, if you want to change the request from this page, this service name to some other name, you can do it very easily. But if you go with class file, you want to give a new build and you want to restart the server. So here, nothing is required. Just you change the web.xml or CSS or JavaScript or any front end, right, which sits in this web content. Anything in the web content, you can change it so it will be reflected in the browser immediately. Just in browser side, you want to close and open the browser. But if it is a class file change, then you want to restart the server. So both names should be same. Servlet name, both names should be same. And let me say let the URL will end with anything. Let the URL end with anything. It should go to our servlet com.front front dot HCLLOSERVLET. Now we need to give this name in our default web. So here we'll make it servlet web. So by this we can know like what are the advantages of annotations and so annotations are replacement for the configurations rather than doing the configurations in the web.xml, right? We can make use of annotations and we can directly do the configurations here like at web service or at web servlet or at configuration, at services, at entity class. All those things we will see in further Spring and Hibernate sessions. Like in Spring, we will use at component, at config, at bean, all those things. So server got restarted. Let us try to do once again. Okay. Let's go JSP host. Okay, okay, I need to restart this server. Or just okay, need to restart it. Okay, just practice this, okay, and move to next slide. So I have the same code here. We created one servlet, and here are the configurations like servlet, servlet type, servlet mapping. The servlet should end with servlet if it ends with SCRV1. SCRV1 is nothing but in our HTML page we have something called SCRV1. We're going to have SCRV1 in our page actually. So once a request ends with that pattern, right? So then we will post the request to this servlet, chapter 1 servlet. Okay. So now it restarted, and let me say server should end with this name web. So I'm going to post remove this and I'm going to post it. So if it ends with this URL, right? So we will post to that URL. If it becomes here, right? We will post it first. So that's it. And then we will do one result and okay. So let it restart and then I'll open the second site. So okay, next slide is all about Spring Web MSC framework. Okay, now it works. So see, URL ends with web, right?
Yeah.
Colon web. So if it ends with web, we have a configuration we did here. If it's going to end with web, we're going to pass the request to this servlet, and here we have the do get and do perspective. So we're going to do that. So initially we were using annotation servlet, but now without using the servlet, right? We are trying web servlet at web servlet. So now we're directly using this. So in our web service tutorials, okay, in our web service tutorials using JaxWS or something, we will use the service.
Okay.
And in our Hibernate, we will make it entity. We don't have the jars, Hibernate jars. Once you put the jars in the build path, we'll use entity. In Spring, we'll use something called component.
Okay.
And we will also use the service level class. So this is front layer, okay? This is front layer. Similarly, if we have service level service package, all the classes in the service layer will be annotated with service. All the classes in the repository, like a DAO layer, we will make it as repository. That if you go SATO or repository. And then, yeah, if it is a bean, we will configure it as bean. And a lot of annotations are there, we will see this slowly one by one. And if you are creating EJB, right? EJB stateful stateless session, in EJB we will see like we will make use of this EJB.
Okay.
So just I'm telling something like we will see all those things in future. So in second class we will see about what is container and why we need a container, what container is going to do, how we need a container, no Java, like how the container is going to perform the action, how it is going to handle the request and response lifecycle and everything. So what is container? Servlet don't have a main method, right? So if you see standalone Java application, we will have a main method, public static void main.
Yeah.
it is going to start the thread, new thread, and from there and the thread will take care of the program, entire program. But in Servlet, we don't have any main method. They
Yeah.
are under the control of another Java application called container. Container, Tomcat is a container, a web container. Okay, J2EE has a EJB container. Spring
Okay.
framework, we have something called IOC container.
Okay.
And for JMS and all, there is something called MQ series, which is also a messaging container which has producer and consumer and JNDI lookup and all those things.
Okay.
So this container is going to take care of lifecycle of the request and response. It will create a new thread for each and every request.
Yeah.
So there is something called client. Okay, client one is posting a request to a first a container will receive it. It will create a thread
Okay.
one, and it will find a mapping servlet. Who is the servlet responsible for this thread or client?
Okay.
So here in our case it is allow servlet, right? Allow
Yeah.
servlet. So it will map this request to the servlet.
Okay.
Let's say client 2 logs in. He is posting some request,
Mhm.
and we will have thread 2 created by this container, same container. And here this time, here this servlet will be another instance of this servlet, and this thread 2 will take care of handling the client request, client 2's request,
Mm.
by passing the request to the servlet and getting the response and again sending back
Yeah.
the response to the client. So let's say client n, there could be n number of clients, so n number of threads will be created by this container, and each and every transaction or request is going to be independent, and that is how there will be a multi-threaded environment in web application.
Yeah. Okay.
So here is some example, like a client is going to post a request to a web app, and web container is going to read the XML file, and it is going to identify the request URL. So okay, this is the URL which is
Yeah.
ending with web. So I want to give this request to this servlet who is going to take care of this client. So like that we have a mapping file, right? Web.xml file. By reading the web.xml file, it will load everything into its memory, and it is going to identify the URL based on the URL pattern. It is going to do the service.
Okay.
Again, while sending request also, so once servlet is done with its own service, it is going to read the uh, it is going to identify the client to which it needs to post the response, and it will post it actually.
Okay. Okay.
When your web server application gets a request for servlet, the server hands the request to the container in which servlet is deployed.
Okay.
It is a container that gives servlet HTTP request and response, and
Okay.
its container that calls the servlet methods doGet and do, and the container is going to call doGet or doPost.
Okay.
So how container will call is like there is something called do service. There are lifecycle methods in servlet like init, service, destroy. Init is like initialization block where all the initialization we can do it, like creating database connection and all those things. And
Yeah.
in service we will call either doGet or doPost. We will call container will call.
Okay.
And then also in between there are a lot of listener methods like application context listener,
Okay.
okay, and session binding listener,
Yeah.
and request listener, request attribute listener, and all those things. So that listeners, those listeners will do is those listeners will listen for any event. Like there could be a request coming in. So
Yeah.
this listener will be notified. Okay, there is a
Oh,
request coming in. So I will intercept the request and send it to the service method. So those interception are nothing but filters. We can have many filters,
yeah.
and all the requests could pass to this filter, and we can log the request which is coming through this filter for auditing purpose, and we can, or for some business reports like number of users logged in per day, all those things. So we'll see all those things. Like, so here what happens, like once a user clicks post the request to the container, user clicks the link that has a URL to a servlet instead of a static page. So container sees the request is for a servlet. So container creates two objects. One HTTP servlet response and HTTP servlet request, two objects. So container finds the correct URL based on the correct servlet based on the URL in the request and creates an or allocates the thread for that request. So here you could see it, our thread will be created, and container is going to create a thread for that request. So for each and every request, we will have a thread created by this container, which is nothing but our Tomcat container, and passes the request and response object to that servlet thread.
Okay.
So this thread, so here two objects are created, request and response, right? So these two objects are sent to this thread, and this thread will bind this request and response to the servlet. So this thread will take care. I mean, what I was explaining is like here in this slide, before slide, a thread is going to bind all the requests in response to the servlet.
Okay.
And here in the fourth phase, container calls the servlet service method depending upon the type of request. It could be a do get or do post method. So service method calls either do get or do post in this servlet, which is our hello servlet. In this example, we assume that request was HTTP get, so HTTP do get will be called. So do get method generates a dynamic page and stuffs the page into the response object. Container still has reference to the response object. So it is going to bind it, all it is going to process the request, and it is going to do service whatever the client is requested for, and it could be like save operation or insert into database or read from the database and or get the list of employee, get the student's name, or check whether the account is valid or not, or credit card information is correct or not, all those things. It could be anything. It is going to process that. It is going to set the response object and give it to a container. Container is going to give it to the result to the response using HTTP protocol. And once it has responded, all the request, response, thread, everything is dead. Garbage collector will come and it will remove all the objects, whatever it has collected from the container, from the server. So do get method generates a dynamic pages. Okay, here thread completes and container converts the response object into HTTP response, sends it back to the client, and then deletes the request response object. So what if we had Java but no servlet or container? What does the container give you? So if we don't have servlet or a container, what do you need to do to have the container logic? So what a container is going to give us is like it is going to give us all this support, like communication support, lifecycle management, multi-threading support, and declarative security support, and JSP support. Socket, server socket, listening to port, creating streams, request and response streams, and lifecycle management like life and death of your servlet, loading the classes, instantiating and initializing the servlet, invoking the servlet method, and garbage collection. So if the threads are not used right, it could be removed, right? So garbage collection, it will run a garbage collector periodically, or it could be for every 1 hour or 2 hours. So it will come and it will remove all the null reference objects from the server container. So create a new Java thread for every servlet request it receives. With container, you get to use an XML deployment descriptor to configure security without hard coding it in your servlet. So if it is like configuration, right, we can directly configure that, and you don't want to give any new builds or any new patches. Directly we can hit the URL and it will work properly. And you can manage and change your security without touching or recompiling your Java source code, Java class files. JSP support, do you think care of translating the JSP code into real Java? Of course, the container. So in JSP, right, what happens, right, JSP is internally a servlet. So whatever you see at the front end, there is a phase, like it is going to convert into servlet, and then it is going to, there is some translation phase in JSP, you will see that. And those translations or everything taken care by the container, Tomcat container, web container. So here's the second example, uh, another servlet which extends HTTP servlet, and we have a print writer method, and how a container found the servlet URL plus XML.
Okay.
So we have a URL, right? It is going to map for this, it is going to search for this pattern, a public
Okay.
2. Once it found, who is going to find? Container is going to search for this pattern in the URL. If it, once it finds, it is going to map the request to this servlet. What is the class name, right? FOO servlet 2 is going to map to that servlet. If it is URL ending with public 1, it is going to map to servlet 1.
Okay.
So mapping servlet name improves your app flexibility and security. So user, client, right, they will know only this URL. They won't know what is the class behind that. They won't know which class and where the logic is written. So there comes the security. Using deployment descriptor to map URL and servlet, it also gives another feature, like we can directly change this URL pattern. If you want to add few more patterns, right, we can add it here.
Okay.
That flexibility is also there. And deployment descriptor XML. So here in XML, right, this one, in this XML, we can do all our security considerations. If any exception is thrown, we can route it to error.jsp. We can have some tag libraries like struct tag libraries or jQuery tags. All those tag libraries, you can have it, and you can write few tags. And initial configuration information you can have, like JDBC connection properties, you can have it here. There is something called init properties and init parameters and context parameters at servlet level and at the application level. You can do that, and it's fully J2W server in deployment descriptor. So which means all those things you can, if you include in XML, right, it will become a full J2W server. All security roles, error pages, tag libraries, and initial configuration information, everything.